Okay, so looking at question 7, when we compared the side length ratios of all 4 triangles in the table, what did we notice? So take a minute to think about what did you notice about that. Okay, here's what I noticed. No matter how big or small the triangles were, the ratios stayed the same. Okay. And we could expand and say the triangles had proportional side lengths, but this is okay. This is good enough. Okay. So question 8 says, compare your measurements and ratios with those of your classmates. What do you notice? So take a minute to compare your piece of paper with somebody else's. Look at their table, show them your table. Ready, set, go. Okay. By now, if you haven't already paused the video, make sure you pause it and share your table with somebody else and then come back. Okay. So by now, you have shared your table that has the ratios with somebody else. Okay. So you've looked at their table and you've seen their side lengths, and these should be different, right? It should be different because not everybody's going to be able to draw their side lengths in exactly the same place. But these numbers should all be very close to each other. These ones should basically be the same, and these ones should be very, very close. So what did you notice? Well, I noticed that even though my classmates had different side lengths, the ratios were approximately equal. They were about the same. Right? Okay, so now we're going to start with our first trigonometric ratio. We're not going to name it yet because that's the next section, but we're just going to start explaining what it is first. And we're going to calculate the slope of the hypotenuse in each of the 4 triangles. And we're going to explain how you got your answer. So if we go back to Algebra 1, what is slope? Right? Slope is rate of change. And our formula for slope is rise over run. Right? So let's go back and let's look at our triangles that we drew, and let's see if we can identify some rise and run type stuff. Okay, so here is our triangle. So if this is my reference angle down here, then my rise is going to be the up and down part. And then my run is going to be here, right? So it's going to be basically opposite over adjacent. Okay? So let's calculate what those were for each of those triangles. And we actually already did it. It's on the previous page, right? It's right here. Opposite over adjacent. These are the slopes of those right triangles. And if we were actually going to put this triangle on a coordinate plane, this would have a slope of 1. See how it's going straight at like a perfectly diagonal line? For every 1 unit that it goes up, it goes over 1, right? So let's write down that our slope for each of those triangles is 1. So the slope is rise over run, which is opposite over adjacent and all of the triangles had a slope of 1. Because we calculated this in the table, right? This table right here. These are the slopes slash opposite over adjacent. And once we get even more advanced, we can start abbreviating and stuff. Okay. And that's page 662, all done there.